Hi class, and welcome to our lesson on 7-8 day 2. We're still talking about inverse functions. So looking at this first one, if we want to verify that two functions are inverses of each other, we could graph both of them and see if they're symmetrical over the line y equals x. Or another thing that we could do that's equally important to talk about is we could put g into f, which is f of g of x, and we could put f into g, which is g of f of x. And once we do that, if what the outcome is an x for both f of g of x and g of f of x, then we know that the two functions are inverses of each other. It might sound very confusing in what I just explained, but it's really not as confusing as it may seem. So let's see if this function, y equals 3/4 x minus 6, and this function, 4/3 x plus 8, are inverses of each other. So to do that, we got to find f of g of x. So g goes into the f function. So this right here is going to go into the f function. So we have f of g of x equals 3/4 times x, which x is 4/3 x plus 8. All of that subtract 6. So let's distribute here. 3/4 times 4/3 x is 12/12 x, which is just 1x. And then we have 3/4 of 8 is a positive 6. So x plus 6 minus 6, which means we just get x. So f of g of x is x. We're on the right track to proving if these two are inverses of each other. We now have to do the exact same thing for g of f of x. So that means f has to go into g. So our f function right here has to go into our g function, which is right there. So g of f of x equals 4/3 times x, and x is 3/4 x minus 6. And then at the end we're going to add 8. So distributing again this 4/3, 4/3 times 3/4, again we get 12/12, which is 1x. X, and then we get 4/3 times a negative 6 is a negative 8 plus 8. So obviously a negative 8 plus 8 is 0, so once again we get x. So to answer the question, are these two functions inverses of each other, the answer is yes. In class, on your test, you do have to show all of this work. So you have to prove f of g of x, and you have to prove g of f of x. Both result in an x. That's how you see if they're inverses of each other. You guys pause the video, try this one on your own, please. So we're going to do f of g of x and g of f of x, which means g goes into f. So hopefully you did f of g of x is 3 times 3x minus 4 plus 4. Distributing, you get 9x minus 12 plus 4. We didn't get anything close to getting x, did we? We got 9x minus 8. Clearly, these two are not inverses of each other, so you could just put no. You don't even have to find g of f of x because both f of g of x and g of f of x have to result in an x for them to be inverses of each other. If f of g of x doesn't work, then you could stop right here. No, they are not inverses of each other. So now looking at this one, I now see it on a graph. How can I determine if these two are inverses of each other? Well, I can see if they're inverses of each other by, let's just say that the blue line here is f of x. And f of x, let's pick 2 points. You could use any 2 points to draw a line. So I'm going to pick this point, and I'm going to pick this point. It doesn't matter which 2 you pick, just pick 2 of them. Go left, 1, 2, 3, up 2. So f of x, my function, is at negative 3, positive 2, and at negative 2, positive 4. If the red line is indeed our inverse function, the inverse function should have the points in the other order. So instead of negative 3, positive 2, it should have positive 2, negative 3. It also should have the other point of a negative 4 and a negative 2. So let's see if our inverse does indeed have these points. Write 2 down 3. is this point. Okay, that one works. And left 4. Oh, shoot. Rats. Sorry about that, class. This should have been a positive 4 right here, yes, because I went left 2, up 4 to get this point. So now this should be a positive 4. Here we go. Right 4, down 2. That is this point. So the 2 points that are on f of x are also on the inverse function of x. So are these two graphs inverses of each other? The answer is yes. Let's take a look here at the next problem, which is problem number 4. Let's pick 2 points again on the blue line and call that f of x. So our function of x, let's pick this point and let's pick this point. It goes through 0, 1, and it goes through 1, 3. So if the red line is indeed an inverse, it's going to have these 2 points on it. 1, 0, and 3, 1. We switch around x and y, just like what we did yesterday when we found the inverse linear equation. You just switch around x and y. So, does my red line have 1, 0 on it? Yes, it does. Does it have 3, 1? No, it does not. The red line does not contain the point 3, 1. So are these two inverses of each other? The answer is no, they are not inverses of each other. Why don't you guys try number 5 on your own? Pause the video, try number 5. On number 5 here, class, what you're going to be doing on this one is, again, let's call the blue function f of x. Let's pick several points. In a parabola, it's nice to pick the vertex, which is the point 0, 0. And then let's pick maybe this point right here, which is right 1, up 4. And then let's pick the symmetrical point, which is left 1, up 4. So that means that the inverse is going to have the 3 points 0, 0, 4, 1, switching around x and y, and 4, negative 1, switching around x and y. Let's see if my inverse function of x does indeed contain those. 0, 0, right 4, up 1, right 4, down 1. So yes, my inverse has the points in the opposite order. This one, these two are indeed inverses of each other. So now we have our last thing of the day, and that is to sketch the inverse. So very similar to our last 3 problems, I'm going to find several points for f of x. Here's my f of x function. It's the blue line. Let's pick some points. You only need 2 of them to draw a line, so let's pick 2. Left, 1, 2, 3, 4, up 1. So left 4, up 1. That's 1 point. And our other point is, let's just pick this one. Left 1, up 1, 2, 3, 4. Left 1, up 4. So if I want to sketch the inverse, I'm going to use these 2 points and switch around the order for the inverse function of x. So instead of negative 4, 1, it's going to be 1, negative 4. Instead of picking negative 1, 4, it's going to be 4, negative 1. Okay, let's put these on our next graph, or on the same graph for our inverse function. So go right 1, down 1, 2, 3, 4, and go right 4, 1, 2, 3, 4, down 1. And there we have it. If you have a straight edge, that would be nice to make sure that our lines are indeed straight. And let's label these accordingly. This one right here is our inverse function of x. So there we have it. We sketched it. And again, these should always be symmetrical with the line y equals x. So there's the line y equals x. If you were to fold it on that red line right there, you would get the blue line and the black line landing right on top of each other, which means that they are inverses. So for a line, all you need to do is pick 2 points for f of x and then switch around the order for the inverse function. Now with the parabola, I want you to sketch 5 points. So pick the vertex, pick 2 points to the right of the vertex, and pick 2 points to the left of the vertex. So here's my function, f of x, and I want to sketch the inverse. Well, f of x has 0, negative 2 for a point, right 1, down 1 for a point, and right 2, up 2 for a point. It also has left 1, down 1, and left 2, up 2. So if that's my function, my inverse function is going to have the x and y ordered pairs switched around. So it's going to have negative 2, 0 for a point, negative 1, positive 1, 2, 2 again, negative 1 again, and right 2, down 2. Let's graph all of these points and see what it looks like. So we're going left 2, up and down 0. Left 1, up 1. Right 2, up 2. Left 1, down 1. Right 2, down 2. Whew! And here is my inverse function of x. And there we have it. It should always be symmetrical over the line y equals x, which is this line right here. So if you were to fold that piece of paper, the blue and the red would land right on top of each other. Last one, problem number 8. This is a cubic function. Once again, I want you to pick 5 points. So we could pick this one for f of x. And that is the point 0, 1. Let's go with this one. That's the point right 1, up 2. This point will work just fine. Left 1, 0. What other point can we pick here? Looks like it goes through this one. So that's left 2, down 1, 2, 3, 4, 5, 6. Left 2, down 6. And let's pick one more. Maybe this one right here. That would be right 1 1/2. And up 1, 2, 3, 4, 5. And up 5. So we have successfully picked 5 points for f of x. So now let's sketch our inverse function of x. Switch around the x and y ordered pairs. 1, 0. Hiya. 2, 1. Onward. 0, negative 1. 2 more. Negative 6. Negative 2. And last one, 5, 1 1/2. Let's sketch this sucker. Right 1. Right 2, up 1. 0, negative 1. Left 6, down 2. And right 5, 1, 2, 3, 4, 5, up 1 1/2. All right, and there we have it. So our graph is going to start over here. It kind of zigs up through here and tails off this way. And there we have it. And as you can see here, class, over the line y equals x, these two would land on top of each other, these two would land on top of each other, these two, so on and so forth. So those are good checks as you graph these ones. They should always be symmetrical to the line y equals x. So even if you guys want to sketch that in your graphs, these should always be symmetrical over the line y equals x. So that's our lesson for today. Let me know if you have any questions when you get to class tomorrow.